confusing sometimes when it comes to that stuff.
I mean, it could have been like we didn't have like a topic sentence in one of our paragraphs or something. I mean, it could have been just something like that.
I don't know.
No, I think it looked fine. So yeah, and it was still an A.
Yeah, it's still an A. It's 93 is an A, so I don't think it'll be a problem.
Yeah.
I wonder how Natalie's gonna do for it. I haven't heard from her. Have you?
I emailed her to ask her if she was up for because we had her down for the writer for this week. And I was like, hey, Natalie, we have you down for the writer this week. Are you up for doing it? And she emailed back and said, absolutely, don't you worry.
Okay, good.
So,
as long as she's okay with it, I trust her.
So I was going to send her an email again, and maybe if you want to as well, just send her what you have.
I'll send her what I have.
Yeah.
If anything else, if you need any more information, just let me know. I'll email that too. I'll probably do that after our meeting here.
Okay. I was also going to tell her ask if she could have it done by Thursday night so that we can look through it and kind of help make changes or additions or whatever. So that way it's done by Saturday versus, that way we know that, it all got done.
Yeah.
Yeah.
I agree.
I don't think that. Yeah. I think that that's an appropriate, thing to ask. So perfect. Alrighty. So let's get to the homework.
Yeah, sounds good. I'm ready when you are. I started doing the homework for this meeting, but I will get to that. It was about cheese and taste, but we'll get to the other one.
Gotcha. I worked last night, and so I just did the prep assignment this afternoon, and that's all I had time for. So.
Yeah. Last night, BYU-I's iLearn was down all day, so I couldn't do anything. That was kind of stupid.
I think they do that on purpose.
They did that all day yesterday, and I couldn't even do any of my psych homework or this homework. So I was just sitting there twiddling my thumbs, thinking how I'm gonna do all this stuff today. I was only able to do math today because that's all I had time to do. But somehow I got to get this psych homework due. We started after this. Anyway, so yeah, I feel your pain.
I know. I'm just glad I have quite a few days this week. I'll get it done tomorrow. So.
Yeah. Okay.
Or probably the next day. I'll probably take a day to recover from working nights, and then I'll do it. Okay. All right. So this chart, the 5 assumptions to check in order to do inference for a simple linear regression. How do we check? Blah blah blah. Of note, I felt that first one, that there's a linear relationship between x and y that you have to do visually. You have to look at the linear relationship, and you have to do a residual plot.
Yes, you do.
Now, is that residual plot? It's the same one for the third row, isn't it?
Yes, still the same. You just have to make sure there's no patterns in the residual plot for the first assumption.
Yes.
The second assumption, you got to make sure there's no kind of megaphone shape. I don't know what a megaphone shape is. I have not done it yet, but I'm going to look it up. Do you know what it is?
Will show you. So if you think like the megaphones that police officers use, it's kind of that cone shape. Hold on, let me see.
Yeah, so I don't see a cone shape.
I didn't either. It was wide at both ends, so I felt like it was okay. I think it's just if it's narrow and then widens is what the megaphone shape is.
That's what we're looking for, the megaphone. All right. Yeah. I wasn't sure what kind of megaphone she was talking about, like a circle or a square or whatever.
And probably they should have just said a cone shape where it's narrow.
Yeah, cone would have been nice.
That's what I would have assumed she meant. So, okay, so second row, the error term, epsilon, that it's normally distributed, which you just do a QQ plot after you do that same thing that we did before, where you get the difference. You just do it for the residual.
You make the residuals through your linear regression, and then once you make a residuals data set, you plot that, and then find a QQ of it.
Yes.
Well, you find the QQ plot of it, and then make sure they're kind of close to the line.
Yeah. Hot dog shape, basically, right? Still? Okay.
What?
Still kind of like, is that the hot dog shape, or no, that's linear?
No,
So
no,
they
no,
just have
that's
to be
linear.
close to the line.
This one has to be close to the line. So there's a line, and you got to make sure all the dots are at least semi-close to the line. It can't be
Okay.
hot dog shaped, because if it is, it's
Right.
like it's
Yeah.
not really. It's
Not normally distributed.
not nor. Yeah, the error term, the epsilon is not normally distributed.
Okay.
The variance of the epsilon error term is constant for all values of x. That's the third assumption. How
Yes,
you
and
would do
that's
that is the residual plot, and you would look
yes.
at that and say, is there a megaphone shape inside this? And if not, then it is true.
Okay.
Then it's the assumption.
So it's nice. You really only do three things. You do the linear relationship, the residual plot, which you look at for two different things,
Mhm.
and then the QQ plot is all you really have to do. So the other two are things that you can't check directly. You just assume that it was done correctly.
Yeah, you just have to assume that x's were measured accurately and precisely, and that y's are independent of each other.
Yes.
Which is usually true, considering you have to be doing that when you do the test. But
Right. So basically, we can expect some kind of question in sometime in the next 2 weeks that asks about that, and that we have to assume that they were done correctly.
yep.
Okay, gotcha. Let's see, the formula. No, the beta, is that just, it's the same thing as last week. It's just that they're known constants, and we just call them beta now. But
Yeah.
they're parameters, they're true value, we just don't know what it is.
They're parameters instead of actual
Like statistics.
statistic numbers.
Right.
So, and the epsilon is your error term or your normal random variable term,
Yes.
whatever you want to call it.
Yes. And X is your known constant. Right? Is that what I'm...
X would be your independent variable, and then Y would be your dependent variable. But you don't need to put that. That wasn't in the answers.
Yeah.
So.
I'm just kind of like getting it in my head.
What do they call it? They didn't call it an independent variable. They called it a expected variable or something like that.
Yes.
Last week.
Yes.
So,
Okay.
Okay. Response variable. That's what Y is.
Response variable.
That's what it was.
Okay.
Anyway.
Perfect. All right, part 2, the gharial crocodiles. I made sure I opened the right one again.
Yep.
Let's see. Checking the 5 assumptions. I felt they were all met.
They were all met. Yep.
Yeah, the scatter plot kind of was wide at both ends. It kind of was like almost an hourglass shape.
Mm-hmm.
So I thought they were all good. So null and alternative, the null, that the beta 1 is equal to 0, and the alternative is beta 1 is not equal to 0.
Exactly.
Okay. B, there's no answer.
Test statistic is T, and the value of it is 22.675.
Yes.
That is what I got, and I used SPSS.
Okay, so did I.
Yep.
Yeah, so did I. Although I got a different p value than she did.
What'd she get?
She got like 0.000 something, like four or 5 zeros, and then I like 5.8 or something. I got the 0.001025.
I got 5.0803 times 10 to the negative 13. I did it in scientific notation because it's so far. It's so far out in the zeros. It's like 13 zeros to the right.
Yeah.
So basically, you're going to reject the null hypothesis in this case.
Exactly. Okay.
That's what I said.
Yeah, and this one, stating your conclusion is that you have to show that there's sufficient evidence that there is a linear relationship between the head and body length of the gharial crocodile.
Exactly.
Okay. Confidence interval was easy.
Confidence interval wasn't that bad. I had to look again to figure out how to get it, but it was the same process as doing the other ones. I got 6.704, and then the other one was 8.096.
Also what I got.
Good.
Okie dokie.
All right. Cool. I want to crank this.
This quiz up?
Yeah.
Yeah, let's do it.
Go ahead and close all these. Yes. All right. don't know what my internet's acting so slow today.
Mine is too. Maybe it's cold.
I would think so.
I'm just done. I'm so done with it being cold. Ready for spring.
All right, here we go.
All right, group meeting. Not that homework. Yes. True. Okay. True. What are the non-alternative hypotheses for V1?
Okay, there's only 14 questions, which is not that bad.
No, that's not too
Not
bad at
considering
all.
last time it was like, what, 17 questions?
Yes. Agreed.
That's awful. All right. True linear regression, I said C.
C. That's also what I said.
A residual is the difference between... No.
I'm going to have to go back to the, hold on, I have the...
A residual for an observation is defined as the difference between the observed value y and the value that would have been predicted by the regression line. Remember that equation?
Yes.
That's
the y minus y hat.
Y minus y hat. Yeah. So.
Okay. So, hold on, let me get back to that here. So that's B.
Yes.
Plots
Residual supports using linear regression when.
See, normally distributed with a zero mean. Because you don't want a pattern, right?
You do not want a pattern. Well, it supports using the linear regression when you see a pattern. No, when you do not see a pattern. So it's not A. It's not B. It's D.
Let's see.
The residuals look normally distributed with a zero mean.
That's what I thought too.
That is.
Hold on. I have it up here on random
Residuals
scatter.
you want them to look. It's a QQ plot of residuals that has to be.
No patterns will be consistent of random scatter. Okay.
Okay. Compute the residuals in math self-efficacy data using software. Use the confidence data as the explanatory variable and the response variable. Which statement best describes them? The residuals. Okay. I gotta go back here.
Me too.
Open this. I don't know how many times I've opened up this file, self-effic. Wait, maybe I have it saved on here.
Oh, that'd be nice.
I think I do actually have it saved on here. Just because I've opened it so many times, it thinks that I have. Okay, recently.
So you love it?
There it is, math self-efficacy.
Perfect.
File
Sorry, I'm
not
slower.
found. File not found, of course.
Of course.
Alright, looks like I do have to open it up again.
That's okay. Me too.
Alright, open this guy. What are we using? We are using the confidence data is your X, and the score data is Y.
Ugh, why is it not opening for me? Come on.
Score data is Y. Confidence rating is X.
Sorry, I'm still working on opening mine.
That's fine.
Ridiculous.
Okay. I guess that's hot dog shape. I'm going to assume it is. A residual plot, regression linear, scores dependent, confidence rating is independent. Okay. Compute the residuals for math self-efficacy. Use the confidence data as there. What best statement best describes the residuals? The residuals are all negative, the residuals form a linear pattern, or the residuals are between -40 and 25.
Okay, hold on here. The confidence rating is the dependent, yes?
Confidence rating is independent.
Is it? Okay. And the score was the dependent.
Yes.
No.
Okay. Now I do linear scatter dot. Instead of score now, I use the unstandardized.
Okay, so that looks pretty linear. Is that what you thought too? Kind of wide at the bottom, but it's mostly linear.
Yeah.
Okay.
If that's not the residuals.
Oh, yeah. Let me put that to the residuals here. Okay. Regression, linear, residuals. Okay. Okay, and then the unstandardized, that becomes, the residuals become, hold on, I have to look at the question again here.
Well, the normal plot looks great.
Okay.
However, it does look kind of megaphone shape.
Okay. Now, when you put in the residual data, does that become the x variable?
The residual becomes the y variable.
Y variable. And then the confidence rating stays the independent.
Yes.
Okay. Look at it here. Mine looks random. Maybe did I do it wrong? Mine doesn't look like a megaphone.
No, you're right. It's random.
Okay.
I redid it again. I did it wrong.
Oh, okay.
So,
okay, now the QQ plot for the residuals.
I don't get this. Compute the residuals for the math self-efficacy data using software. I did that. Use the confidence data as explanatory variable and the score data as your response variable. Did that. What statement best describes the residuals? Residuals are between -40 and 25. Residuals are all negative. Residuals form a linear pattern. Well, they're not linear, so it's not. Residuals are not negative because there's some positives in there. Residuals form a linear pattern.
Which they don't.
The unstandardized kind of show, the QQ plot of the unstandardized residuals show a linear pattern.
Mm-hmm.
wonder if that's what they mean.
They could be between -40 and -25.
I don't see a
Let's,
negative
if you
40.
just look at the data, let me go back. Oh, shoot.
I see a 40, I think. It could be 25, but I don't know.
Do you see a -40?
I see something close to a negative 40. It doesn't look like it's negative 40, though. And I see a 25. I'm sure that's 25 up there. It could be B. It could be A.
Yeah, I don't see -40 anywhere either. I've got an almost like a -38. Does it say between? Yeah. Okay.
Okay, if it says between, not necessarily
Exactly.
exactly. Okay. Yep, then it's A, I think.
Okay. I would agree.
7 is the residuals are fairly normal. At least I said that. You can
That's
double
what I
check
said
that.
as well. The Q plot was very.
Given the residuals plot, the QQ plot, and the scatter plot.
Which of the 5 assumptions about linear regression are satisfied by the data? I'd say probably all of them.
I would say all of them.
Yes, the X values are measured without. So the last 2 are ones we assume.
Yeah.
Okay. Estimate for slope here. Let me have to redo that here. Maybe I don't have to redo it.
I got
Oh, I have to.
I got 12.695. Did you get that?
Hold on here. Let's see. For T,
For B1.
for B1. Oh, yes, 12.695. Yes.
Thank you.
Also what I got.
All right. What is the confidence interval for B1? I got 10.674, 14.715, which is not really any of them except the top one.
Okay, which ones did you get?
I got 10.674 and then 14.715.
Why did I get nothing like that? Hold on. Analyze.
Did you get a 95% confidence interval?
I did. You go under linear, right?
Yep.
Oh, I used it on the unstandardized residual. I have to take that out, correct?
Yep.
Okay. Score. Statistics. Continue. Okay. Okay. So you use the bottom number, the bottom row.
Yes.
10.674.
Yeah, because your confidence rating mean is your B1.
Your B1, and the other one is your B0.
No, the other one's like your. Yeah, it's your Y variable.
Oh, okay. Okay. So I got 10.674 and 14.715.
Yeah, which kind of looks like the top number there, but it's a little different. I wonder if it's because it's Excel.
Maybe. Did you use Excel?
I did not.
Oh, okay. Well, I'm cool answering A.
I'm cool answering A as well.
Yeah. Okay. Based on the evidence and using level of significance of 0.5, what decision do you make regarding the B1? Hold on, let me look at my. Okay. It looks like we're going to reject the null here.
Because p-value is less than alpha.
Yeah. Okay. does it mean?
I say C.
Is not 0. Yes, because they're going to be. There is a relationship, which means it's not 0.
Mm-hmm.
Okay, I agree. The dependent is the body length. I'm going to say B on 14.
I would think so too.
Okay.
99% chance that the confidence interval will contain the true value of B1.
B1, yes.
All right.
I'm just going to look and make sure I didn't accidentally change any of my answers here. Okay. All right. Submitting. Wow. What did we get wrong?
What'd you get wrong?
I got 8 wrong. And 14 wrong.
There wasn't a 99% chance?
Oh, no. It has to be confident, not chance. I miss that every time.
Dude, yes. Since the confidence interval does not contain 0, there is sufficient evidence to conclude that B1 is not equal to 0.
Yeah, I'd be A.
Shoot. But what about 8? Why did we get that wrong? There is
well,
clear relationship.
Can we not say the last 2 maybe?
Observations are independent. X values are measured without error. It's not showing me what I got wrong on 8.
Yeah, that's either. Me either. I don't know.
The linear relationship between X and Y. The variance of the error term is constant for all X values. It's not telling you what you got wrong on 8 either.
Nope.
No?
Nope.
The residuals are normally distributed.
The only thing that I can think of is maybe we're not supposed to assume the last 2. I don't know.
Which of the 5 assumptions, given the scatter plot, the residuals plot, and the QQ plot, which of the 5 assumptions about linear regression are satisfied by the data? Probably not.
Yeah, I would have assumed all 5.
I can see it now. I refresh the page. You're not with only the scatter plot, the residuals plot, and the QQ plot. You can only figure out the first 3.
Okay.
You cannot figure out the last 2.
Okay.
Which a bull.
So that's what we did wrong there.
Yeah.
Oh, okay. I just assume we're supposed to assume. Okay, and in 14, I see why I did it wrong. See, that 99% chance gets me every time.
99% chance? Yeah. Every time I think chance, I have to think
Nope, not that one.
proportion. I have to think proportion and probability. But if I think math, like if I think qualitative data, no quantitative data, I have to think 99% 99% confident.
Yeah. Okay.
When we're talking about confidence intervals, you got to think.
Yes.
You got to think because does it contain 0, and if it does not, then that means we have a pretty strong confidence that it's in there, like it's different.
Yes.
Like, okay.
Yeah. Alrighty. Well, so Thursday is going to be reviewing. Yeah?
Hold on. Hello, what? Yep. Okay. All right.
All right.
Yes, it looks like, I think next week this is project presentations and review for exam 4. Final course evaluation. Ooh. Is there an exam 4 and the project, or is it?
No, exam 4 is the not next week, but the next. If you look under course conclusion, let's see. Lesson 25 is still exam 4.
I wonder if exam 4 is comprehensive.
Oh, absolutely. It's got to be. I
Hmm.
mean, it's like it's the exam 4, and it looks like it's the final.
I would think so.
So, I mean, she's been putting comprehensive stuff in all of the tests.
Yeah, she
So,
has, and in the homework sometimes as well.
yeah. So I bet you it's got to be comprehensive.
Guaranteed. Yeah.
So, it looks like what is that? Yeah. So we have 2 lessons of reviewing
There's a lot of review.
for Thursday and Monday, and I don't see
Final
when.
project. Are we gonna all have to present this? I guess we're all gonna have to present this final project.
Yeah. Where do we present it? Are we? Is she going to come to one of our
Maybe we're gonna
Google?
make another Skype video like this or a Google video like this and present it.
Yeah. That sounds
If
that
I were the
sounds
teacher, that'd be
likely.
what would happen.
Okay. That sounds
This
likely
final
to
course
me.
evaluation. No, sorry, that's not it. Okay.
Where did you see group presentations?
I just see project presentations in 24.
I don't see that.
Final first PowerPoint presentation.
Um,
Open the link, the descriptions, summarize. Open the link below for instructions on how to create a PowerPoint presentation summarizing your study. Okay, so it's a PowerPoint we gotta make.
Yes.
All right.
Does it say when that's due?
It's due Thursday of the concluding week at 11:55.
Let's see. I see Friday, April 10th for the PowerPoint.
Yeah, that's when it's due.
Okay. Okay. So the one Natalie's write-up is due this upcoming Saturday.
Yeah. This next one, don't. I'll come back for it. Just leave it on the table.
Okay.
Or just give it
Alrighty.
to me, Jacob. Just give it to me. Unbelievable.
That's okay.
Okay.
All right, kidding me? Like my kids are like, Mom, do I still have to leave you alone? Mom, do I still have to leave you alone? So it's family stuff. No worries.
Yeah, it's family stuff. I know.
No worries. Okay, so you'll email Natalie. I will also email Natalie and reach out and see if she needs anything.
Yes.
And then I will ask her to have everything done. Well, she'll be watching this, so But
Yeah,
I'll
she'll
email
watch
her.
this and hopefully she'll get along with
Yeah.
her portion of the project just fine.
Yeah.
I
Me
will
too.
email her tonight right after this. I'm gonna do
Okay.
I'm gonna do the homework part after we do this, and
Okay.
if there is anything that we need to do for the PowerPoint presentation,
Mhm.
I don't know how we want to do it. Do we want to do I guess we can talk about that on Thursday, but
Yeah.
I mean, just kind of start thinking about how we're gonna divide up. I mean, we can all do a part of the PowerPoint that we did, but
Yeah. That's
we all
kind of what I was
I think
thinking
we all have to be involved in the
in the PowerPoint.
in some parts like
Yeah.
the inferences, the take action maybe, or just like the overall. There's some parts where we just all need to participate. I
Right.
have to look at the rubric.
Yeah. I'll have to look at it too. I think what you and I had decided initially is that we'll each be over the PowerPoint presentation
Yeah.
based on the part that we were the main writer for, which I think is probably good.
Yeah, I agree.
Since we'll, like we all have that data. So I think this will be good. I think it'll be good.
I think so too. Yeah, we shouldn't
Yeah.
have a problem. We've been acing every part of the project so far. So, last part we'll see what we can do, and after that we'll make a PowerPoint.
Yeah, we should be good. Should be good. All right, Josh. We'll see you Thursday at 11.
Thursday at 11 sounds fine with me. I'll be
All
there.
right. Well, have a good night's sleep. I will not have one.
I'm sorry. Don't worry. I'll be at
Sleep
work
for
tomorrow anyway. Yeah.
me. All righty.
All right,
Talk to you later.
good luck.
Thanks.
Okay. We'll see you.
Thanks. You too.
Take care.
Bye
Bye.
bye.